The purpose of this video is to guide you through the process of drawing the orbit of Mars using Tycho Brahe's data. It is assumed here that you have already read the article and that you are generally familiar with the lab. If you are not, please read the article and then come back to this video. So, each pair of data points on the table on page 2 corresponds to one particular position of Mars in its orbit. So the first two lines correspond to the position of Mars in the same place in its orbit. So for example, Mars would be over here, and both of these points correspond to the same position of Mars. The second pair of data points correspond to the position of Mars in a different place in its orbit, for example down here. And the subsequent pairs, which are not shown in this screenshot, the subsequent pair correspond to other places which you will not be using in the lab. So you will only be using the first two pairs of data points. Now, here the orbit of Mars is already drawn. Of course, in reality, you do not know where the orbit of Mars is. All you know is the general direction of Mars in the sky at a specific time of the year, at a specific date. So, looking at these data points, you have two columns, heliocentric longitude of Earth and geocentric longitude of Mars. First, let's discuss the definition of longitude. It is measured from a reference point, which is known as the vernal equinox point. This is a general direction in the sky or in the celestial sphere, which is symbolized by the ram symbol, and it corresponds to the position of the sun, the direction of the sun on the vernal equinox or spring equinox. This is something you will elaborate in class during chapter 4. So, all you need to know is that the vernal equinox is the 0 degree in the celestial sphere. So any angle measured will be counterclockwise in reference to the vernal equinox point. It is strongly recommended that you use a ruled paper, so straight parallel lines, to help you orient your protractor. So all the lines would correspond to the vernal equinox. As you can see in this screenshot, I am using ruled lines that are in parallel with the vernal equinox point. So, the first column indicates a position of Earth. So, for example, the first point, 159 degree and 23 minutes of arc, is heliocentric, meaning you place the center of your protractor at the sun. This circle here is the orbit of Earth, and starting from the vernal equinox direction, so here it would be, this point here is the 0 degree, you go counterclockwise, centered around the sun, heliocentric, and you find 159 degree and 23 minutes of arc. So it is important to take into account the minutes of arc and use a position in between two divisions, which are a degree apart in your protractor. The divisions are 1 degree apart, so you have to go in between the division as accurately as possible, find the 23 minute of arc. That will be the position of Earth around the sun. That would be the position that Earth was around the sun when this second angle, which is the position of Mars, was measured. This position is geocentric, meaning that it was measured from Earth, and that direction is again relative to the vernal equinox line, except that the vernal equinox axis is drawn starting from the position of Earth. The Earth should be the center of your protractor now. Starting from this point, you're looking for a direction for Mars 135 degrees counterclockwise from the vernal equinox direction, centered with Earth. This is geocentric. So, where is Mars at that time? On February 17, 1585, going counterclockwise 135 degree, you know that Mars is generally in this direction. You do not know how far. Again, make a very accurate measurement of the angle. On 1587, January 5th, Mars will be back at the exact same position in its orbit. So you will be using a technique known as triangulation. You're looking at Mars, which is at the same position, but you're looking at it from two different angles, from two different places on Earth, and you use triangulation to locate the exact position of Mars. So for the second point, starting with the Sun, the position of Earth is 115 degrees. Going counterclockwise, you locate a point 115 degrees and 21 minutes. From this point, drawing the vernal equinox line, you are going to locate the direction of Mars, which is 182 degrees and 8 minutes. So this should be slightly below, and you would have a second observation of Mars. Mars is at the same place, seen from a different angle. The two lines intersect over here. This is where Mars is in both of these dates. You will repeat the same process for the second pair of points, which should give you a point on the opposite side. These 2 points correspond to the perihelion and aphelion of Mars. The line connecting these 2 points corresponds to the major axis of Mars. Once you find the center of this major axis, you can take your compass and draw a circle, which will be an off-center circle relative to the orbit of Earth. This would be the orbit of Mars as an approximation, being a circle. Then you can follow the rest of the instructions and do all the calculations. Whenever an angle is measured, for example, the parameter L, whenever an angle is measured, remember that you start with the direction of the vernal equinox and you go counterclockwise.